Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October November 2023, paper 1, variant 1. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 11 says a minimum torque of 20 newtons meter must be applied to the lid of a jar for jar to open. The radius of the lid is 4.0 centimeters. What is the minimum force F that must act on each side of the lid in order to open the lid? This question is simply about torque of a couple. So simply we can say torque of a couple. Torque of a couple. So this question is simply about torque of a couple. So we can write down this couple in a better way. Torque of a couple. And torque of a couple is equal to the product of one force time perpendicular distance between forces. So we can say perpendicular distance between forces. So if you look at this given figure, so we can draw this horizontal line here. So we have two forces in this case, one force here, another force is here, and this is at an angle of 90 degree and this is also at an angle of 90 degrees. So this is the perpendicular distance. We can say this one is perpendicular distance, and this distance is equal to 2 times of radius. So we can say this is equal to 8.0 centimeters. Now everything is given to us. We have the value of the torque, so we can write down this is 20 newtons meter. We have to find value of F, but we have value of perpendicular distance, that is 8.0 centimeters. So it means this is 8 times 10 to minus 2 meters. So if we simply solve this one, so we have 20 newtons meter divided by 8.0 times 10 to 2 meters, and our final answer in this case will be equal to 250 newtons. So this is how we can figure out. Pretty straightforward question. So the main concept is this one: how to calculate torque of a couple. So the answer for this question has to be C. Question 12 says a uniform bar of length capital L and weight W rest horizontally on two supports X and Y. Support X exerts a vertical force Rx at a distance of L by 6 from one end of the bar. Support Y exerts a vertical force Ry at the other end of the bar. The bar is in equilibrium. What is the ratio between Rx and Ry? For this question, it is given to us, it is in equilibrium. Even if it is not given to you, it is in equilibrium. In most of the cases, you can assume that it is in equilibrium. For this question, they have specified this is in equilibrium. Equilibrium simply means that sum of the forces in any direction is equal to 0 and resultant moment about any point is also equal to 0. We can say resultant moment about any point is equal to 0. We need to find the ratio between these two forces, so we can take our pivot point at the midpoint of the beam, at the midpoint. So we no need to worry about weight. You look at the given options, we don't see weight in the answer, so it means we should take our pivot point at midpoint of the beam. Now simply we need to find out this distance. So let's say this distance is dx and this distance will be equal to L by 2 because the length of the beam is given, that is L. So how we can find out dx? Dx simply we can find out this will be equal to L by 2 minus L by 6. Now if we take LCM, we will get 6 and here we will get 3L minus L. So this will be equal to 2L by 6, or simply we can say this is L by 3. So this is value of dx. Now simply we have to take moment about this point. Moment due to this force, this moment will be clockwise. Moment due to this force, this will be anti-clockwise. So we can say Rx times L by 3, this has to be equal to L by 2 times ry. We need to find out the ratio between rx divided by ry. So we can simply write down, we have L by 2, this will be multiplied by 3 by L. Now we can simply cancel L with L, so we left with 3 by 2. So this is our final answer. Simply we need to find the ratio between these two forces. So the answer for this question has to be A. Pretty straightforward question. Just read question carefully. You will be able to find the answer. Question 13 says, a type of firework is made by connecting two rockets facing in opposite directions to a rod as shown in the figure. The rod is attached to a frictionless pivot so that the firework can rotate in a vertical plane. The firework has weight W. The pivot exerts a force capital R on the rod that is equal and opposite to W. Each rocket exerts a force of magnitude F on the rod at a perpendicular distance D from the pivot. The forces exerted by the rockets are always in opposite directions. Air resistance is negligible. Which statement is correct? So first of all, if you look at the forces, mean the sum of the forces acting on this firework, you can see these two forces are equal and opposite, and this force is equal and opposite to this one. So it simply means that resultant force is equal to 0. Now if you look at resultant moment, if we take our pivot point here, so moment due to these two forces will be equal to 0, and moment due to this force, this moment will be clockwise, and moment due to this force, this also will be clockwise. It means net moment is clockwise, is not equal to 0. It means that this system is not in equilibrium. So we can simply say not in equilibrium. So this is not in equilibrium. Now if you look at given options, it is given to us the firework is in equilibrium. This is incorrect. Is in equilibrium. This is also incorrect. Is not in equilibrium because the resultant force acting on it is not 0. This part is correct, but this one is incorrect. The firework is not in equilibrium because the resultant torque acting on it is not 0. So the answer for this question has to be D. So this is how you can answer this one. The main concept is this one. This is the main concept. If it was in equilibrium, resultant moment has to be equal to 0. As in this case, resultant moment is not equal to 0. It means this is not in equilibrium. So this will be rotating. So it has clockwise moment. Question 14 says, an object of weight W is suspended from a Newton meter. When the object is completely immersed in water, the Newton meter reads P. When the object is completely immersed in oil, the Newton meter reads Q. What is the ratio between density of oil and density of water? So in order to answer this question, first of all, we have to look at the forces acting on this object. So at this point, the weight of the object, this is acting vertically down. So we can say W is the weight of the object. And there is up thrust on this object that is acting vertically up. So we can say this is U. And also there is spring force that is equal to P. So in this case, simply we can write down up thrust. This will be equal to W minus P. So up thrust on the object when it is in water, so we can say this is U W. Now if you look at forces acting on the object when it is inside oil, we can write down here the weight of this object will be acting vertically down. There is up thrust on this one, that will be up, and the spring force is also acting vertically upward, that is equal to Q. For object, we can write down up thrust when it is in the oil will be equal to W minus Q. So this is, first of all, we can write down. Now we need to find out the density. As this is the same object, it means that volume is the same. And we need to understand upthrust is equal to rho times V times G. So this is equal to W minus P, and this is the density of water. Volume in this case is the same because the same object in two different fluids. So we can say this is our one equation. Simply we can say this is one equation. We can also write down upthrust in terms of density, volume and G. So we have density of oil, so we can say this is density of oil times we have V times we have G. This is equal to W minus Q. We can say this is second equation. For this question we have to find the ratio between density of oil and density of water. So simply we can divide 2 by 1. So here we have, this is 2, so we have density of oil times V times G. This is equal to W minus Q. We need to divide by 1, that is density of water times V times G, and this is divided by W minus P. W minus P. So simply here we can cancel this V with this V, this G with this G. So we left with density of oil divided by density of water. This is equal to W minus P. This is W minus Q. We have Q. So this is W minus Q divided by W minus P. So this is our final answer. So the answer for this question has to be W minus Q. So W minus Q. So this is W minus Q divided by W minus P. So the answer for this question is D. And this question is a repeated question. You can also see in other past papers. So this is repeated question. I hope this makes sense to you. Question 15 says a crate of mass 50 kg is pushed a distance of 6.0 meters along a horizontal surface against a constant resistive force of 70 newtons. The crate moves at a constant speed. It is then lifted at a constant speed through a vertical distance of 1.2 meters onto the back of a lorry. What is the total work done in this process? Means what is the total work done by the person in this process. So this is better way to say this one. Total work done by the force applied by the person. So how we can answer this question? The best way to answer this question is simply we can sketch. So this is the horizontal surface, then we lifted this block and you can imagine this is the back of the lorry. So first of all, block was moving at constant speed at horizontal surface. So resistive force in this case is given to us Fr, that is equal to 70 newtons. So the applied force on this object has to be equal to 70 newtons as well. And in this case, as speed is constant, so the work done by applied force is equal to the work done by friction. So the net work done on the block will be equal to 0. So we can say W1. W1 is the work done. That will be equal to F times T. So simply that will be equal to 70 newtons times the distance 6 meters. And then we lifted this block, lifted. Delta H is given to us, that is equal to 1.2 meters. We lifted this block to the back of the lorry. So lifted to this certain height. So this is our block here now. When we lifted this block, work done will be equal to the change in GPE because speed is constant. So we can say this is W2. So the total work done in this case, we can say W total. This will be equal to W1 plus W2. And so we have 70 times 6 plus change in GPE, that will be equal to mg delta H. So we can also write on mg delta H. Weight of mass of the block is given, that is 50 kg. So we can say this is 50 times 9.5 1.81 times height, that is 1.2. So this is the total work done by the person. Now if we solve this one, our final answer will be equal to 1000 joules. So the answer for this question has to be D. Question 16 says the input power to a television is P in. The useful sound and light power emitted by the television is P out. What is the efficiency of the television? So first thing we need to understand, efficiency is simply equal to useful P out, useful E out, energy out, divided by total input power. So for this question we have useful P out, that is simply equal to P out, and P input means total input power, that is equal to P in. So the answer for this question has to be a quite straightforward question. Question 17 says a builder holding a brick of mass 300 grams drops the brick on his foot. What is a reasonable estimate of the change in gravitational potential energy of the brick? For this question simply we need to understand average height of a person. So we can say average height of a person. Average height of a person can be about 1.70 meters. Now this person is holding a brick and drop this in. So simply you can imagine as I'm holding this brick. So this is the brick I drop from here. So what is the height? Average height. So average height means the change in height average can be about 1 meter, roughly 1 meter. So we can calculate the change in GPE now. That will be equal to mg delta h. Mass of the brick is given, that is 300 grams. So we can say 3000 grams means times 10 to minus 3. You have to convert this one into kgs and multiply by 9.81, and the change in height approximately we have said is about 1 meter. So the final answer will be about 30 joules. This is a reasonable estimate. If you have estimated average height is about 1.7 meters, or even if you have estimated between 1 meter to 2 meters, still your answer will be right. So it's a reasonable estimate. It cannot be 300 joules. It's a very high number. This is also very high number. This is also very high number. So the answer for this question has to be A. Question 18 says an elastic cord of unstretched total length 16.0 centimeters and cross-sectional area 2.0 times 10 to minus 6 meter square is held horizontally by two smooth pins, a distance 8.0 centimeters apart. The cord obeys Hooke's law. A load of mass 0.40 kg is suspended on the cord. The angle between the two sides of the cord supporting the load is 60 degrees. What is the Young's modulus of the cord material? A typical question. So for this question we need to calculate Young's modulus. And so simply we can write on here Young's modulus. This is equal to stress over strain. So simply we can say stress over strain. And stress is F over A divided by delta L by L naught. If we rearrange this one, we will get F times L naught divided by delta L times A. So this is delta L times A. For this question, we have value of L naught. So this is L naught. Original length of the string is given to us. A is given to us. So this is the cross-sectional area we have here. Now first of all, this is 16 centimeters long, but now if you look at this one, this is 24 centimeters long. So we can also find out value of delta L. So delta L will be equal to 24.0 centimeters minus 16.0 centimeters. So we have 16.0 centimeters. So we can say delta L is equal to 8.0 centimeters. So we have L naught, we have delta L, we have A. Simply we need to find out what is value of F. But F is very tricky one. Most of the time student, they simply remember this one. This is the force. But this is the force, this is the force acting on the string. This is the tension in the string. So what is F here? Most of the time students, they get confused with this. It not means that only the force acting on this one is the weight, so F is equal to weight. No, this is tension in the string. Very important one. What is this F? Tension in the string. So very important one. So what is F? F is tension in the string. So now simply we need to find out tension in the string. How we can calculate tension? So first of all, we need to understand tension here. This is acting up, so this is value of T. So tension here is also up. So we have to find out value of this T. And this T has two components, so we can draw here. We can draw one component is here. So this is the horizontal component of tension, and this side also has horizontal component. We can draw, this is the horizontal component, but this also has a vertical component. Vertical components we can draw here. So it has a vertical component, and we can draw here, it has a vertical component. So we can add arrows here. So tension is this way, this tension is this way, this component is up, and this component is also up. This is up. We can say this is Ty, we can say this is also Ty. Now we need to understand, if this angle is 60 degrees, this angle is 60 degrees, this angle also will be 60 degrees, this angle also will be 60 degrees. So we can say this angle is 60 degrees, this angle is also 60, so this angle also will be equal to 60 degrees. So from here we can say mg, this will be equal to 2 times of Ty. 2 times of Ty means Ty, these are two forces acting up, mg is down, so we can say this is equal to 2 times Ty. But Ty is equal to, so if this is T, so this will be Ty will be equal to T sine of this angle, that is 60 degrees. So we can say 2 times T sine of 60 degrees. We need to find out value of T, so we can say T will be equal to mg divided by 2 sine of 60 degrees. Now simply we need to plug in values. We have value of mass, that is equal to 0.40, then we have value of g, that is equal to 9.81. we need to divide by 2 sine of 60 degrees. If we solve this one, our answer will be about 2.2655 Newton. So this is value of T. Very tricky question, but very conceptual. Which force you have to take when you need to calculate Young's modulus? That is tension in the string. Now simply we can plug in values here. We have 2.2655 multiply by L naught, that is 16.0 centimeters, multiply by 2, and delta L we have, that is 8.0, so this is delta L. 8.0 centimeters means 10 to minus 2, and value of A we have, that is 2.0 times 10 to minus 6. Now if we solve this one, we will get our final answer. And in this case, value of Young's modulus will be equal to 2.3 times 10 to 6 Pascal. So the answer for this question has to be C. So this is how you can calculate. Very nice question. If one time it is not clear to you, watch this video again and try to clear your concept. So F is the tension in the string, and this question is a repeated question. If you check May-June 2020 paper 1 variant 2 question number 18, the same question is there. So this question is repeated question. Beautiful question, conceptual. Try to understand this. Question 19 says, which force extension graph shows plastic deformation of a sample of material? So simply we need to understand what is plastic deformation to answer this question. Now let me ask you one question, very nice question. Place your finger on your cheeks, you will see the shape of your cheek will change. Now if you remove the finger, your cheek will come back to original shape. Now is it plastic deformation or not? I hope you will say this is not plastic deformation because your cheek deformed temporarily and now it is back in original shape. So this is not plastic deformation. This kind of deformation we call is elastic deformation. So we call this is elastic deformation, mean it deformed temporarily. So we can say deform temporary. So deform temporary. So it returns to, so we can say returns to original size and shape. Original size and shape when we remove the force. Now we need to understand what is plastic deformation. Plastic. So let me explain you what is plastic deformation here. Plastic deformation. So plastic deformation simply means that deform permanently. So we can say deform permanently. So we can say deform permanently and does not return to original size and shape. So that kind of deformation we classify as plastic deformation. Now if you look at this given option, you can see this we apply force, this deform. So it has this much extension at this point. But when we remove the force, it again come back to this. So it means it was deformed temporary. So this is elastic deformation. So I'll be just writing E for here. So this is elastic. It deformed temporary. Now if you look at this one, so when we apply the force, it extension in this one is this much. But when we remove the force, it come back to this point again. So it means there is no extension when we remove the force. So it means this is also elastic. Now if you look at this one, first of all, when we apply force, if you look at the loading curve, we have this much extension at this point. But when we remove the force, if you look at the unloading curve, at the end there is no extension. So it means it was deformed temporary. So this is also elastic deformation. I hope now you understand what is elastic deformation. Now if you look at the last option, when we apply force, if you look at the loading curve, it has this much extension at this point. But when we remove the force, after removing the force, when the force is 0, so you see it still has this much extension. So this is remaining extension when the applied force is equal to 0. So it means this has been deformed permanently. So this is plastic deformation. So this is plastic deformation. I hope this is clear to you. Now you understand what is elastic deformation and what is plastic deformation. I hope next time you can answer this type of questions with confidence. And if this video was helpful, please like and subscribe, and also leave some comments in comment section. And if you need more help and you are looking for extra resources, please join Patreon. On Patreon you will see a lot of resources, and the link for Patreon is in the description of this video. So we will stop this video here, and next video will be coming very soon. See you in next video.